Today's lesson is on linear equations in two variables. This is section 1.3 in your textbook. The essential question for this unit is, what is slope and how can it be used in conjunction with linear equations? First of all, let's address the whole idea of what exactly is a linear equation. All right, a linear equation is what you'd expect. It is linear. It is an equation that forms a straight line. And if it's in two variables, we have two unknowns, we have an x and a y. Probably the simplest form of linear equation is an equation of the form y equals mx plus b. Now you see x and you see y as being the unknowns or the variables. Now what do we mean by m and what do we mean by b? So m is simply equal to the slope of the line, or put in another way you could say the steepness of the line, how steep that line is. Is it going close to vertical? Is it close to horizontal? So m therefore is the slope of the line. On the other hand, b is equal to the y-intercept, or where the equation or graph crosses the y-axis. And if you think about it, where the graph crosses the y-axis is where x is equal to 0. So in the equation y equals mx plus b, if x is equal to 0, therefore y would equal b. So y equals mx plus b, it's referred to as the slope-intercept form of the equation. And obviously the reason it's called the slope-intercept form is because you have m the slope and b the y-intercept, hence the term slope-intercept form. So once you have determined the slope and the y-intercept of a line, it is pretty simple to take and graph the line. So let's look at the example where we are asked to graph the equation y equals 2x plus 1. Now, it's fairly obvious from this equation that m is simply equal to 2. Well, what does that mean? That means the slope is 2. Well, slope is defined as rise over run. Now, rise over run is simply defined as how far up you have to go for a given distance horizontally. So, a given distance vertically for a given distance horizontally, or a given distance y for a given distance x, or change in y over change in x. Similarly, it's fairly easy to see that in this case b is equal to 1, or in other words, the equation crosses the y-axis at y equals 1. So if we look at a graph, we can start by saying, okay, b is equal to 1, so therefore I know it goes through the point y equals 1. And obviously x equals 0. So that's one point where it goes through. Now, I know the slope is 2. That means the rise, or the change in y, is 2 for every 1, which puts me over here. And it goes through 0, 1, and 1, 3. Because again, the slope, the change in y is 2, the change in x is 1, so that means up 2 over 1, and there's my line. Going through the y-axis at y equals 1. We can also figure out what it is at where it crosses the x-axis by setting y equal to 0. And if you set y equal to 0, you find that x is equal to minus 1/2. So the x-intercept is minus 1/2. So now let's talk a little bit more about finding the slope of a line. We said slope was equal to rise over run. But let's say we're given 2 points. We're given that the line goes through. We're given a point x1, y1, and another point x2, y2. So as you can see in the sketch, we've got 2 points, like I said. The first point on the left is going to be x1, comma, y1. That's the coordinates of that point. And the next point to the right of that is going to have the coordinates x2, comma, y2. Now, we said slope was rise over run. So if you think about that, we've got a run horizontally and a rise vertically. You've got a right triangle there. And the rise is simply going to be y2 minus y1. So that's y2 minus y1 for that distance. And the run is simply going to be x2 minus x1. And we said that the slope, therefore, was equal to rise over run. So in this case, the slope, or to use the terminology we just used earlier, m is equal to y2 minus y1 over x2 minus x1. And the only thing you have to be careful of is when you have these 2 points, if you pick the x value that's x1, make sure that the corresponding y value for that point is also y1. And similarly, x2 corresponds to y2. You get those values, and then if you know those coordinates of those 2 points, you can figure out what the slope is. So let's look at an example. Let's say we were asked to find the slope of the line passing through the point minus 2, 0 and 3, 1. Well, I can pick x1, y1 for either of the points, but I'm going to say x1, y1 is the first point, okay? So I've got x1, y1 corresponding to the first point, and obviously then x2, y2 is going to correspond to the second point. So therefore my slope, in this case, m, is going to equal y2, which is 1, minus y1, which is 0, over x2, which is 3, minus x1, which is minus 2. Be careful of the signs. So the numerator 1 minus 0 is simply 1. 3 minus a minus 2 is 3 plus 2, so the slope in this case is 1/5 for the line going between minus 2, 0 and 3, 1. So knowing how to calculate the slope of a line, knowing 2 points on the line, leads us to another form of the equation of a line. And this is the point-slope form of the equation of a line. So this form of the equation is simply y minus y1 is equal to m times x minus x1. And if you look at it, this is basically the definition of slope, okay? Now, the only thing we have here, though, that's different is x1, y1 is a known point on the line, and m is the slope of that line, with just regular y and regular x being the variables or unknowns. So let's say we were given an example. Find the slope-intercept form of the equation of the line that has a slope of 3 and passes through the point 1 minus 2. All right? Well, we immediately know that m is equal to 3. Okay? So this right here, the 3, is simply m, and the 1 comma minus 2, 1 is x1, minus 2 is y1. So we got the 3 constants, and we simply can plug them into our equation, which gives us y minus a minus 2 is equal to 3 times x minus 1, or y plus 2 is equal to 3x minus 3. And if we want to continue to go to the slope-intercept form, we can subtract 2 from both sides, and we get y equals 3x minus 5. So there's the equation in slope-intercept form of the equation of the line that has a slope of 3 and passes through the point 1 minus 2. So what do we know about the slope of parallel and perpendicular lines? The slopes of parallel lines are equal, or put it in a more formal way, two distinct non-vertical lines are parallel if and only if their slopes are equal. That is, m1 equals m2. So anytime you've got two parallel lines, their slopes have to be equal. Now, secondly, the slopes of perpendicular lines are negative reciprocals of each other. Well, what in the world do we mean by that? So, if two numbers are negative reciprocals of each other, that simply means if you multiply the two numbers together, you're going to get minus 1. So in this case, if one line has a slope m1 and the other line has a slope m2, and we multiply them together and come out with minus 1, we know that the lines are perpendicular. Or to use numerical values, if the slope m1 were 2, in order for the lines to be perpendicular, the slope m2 would have to be minus 1/2, hence the negative reciprocal. So you take the reciprocal of m1 and then you make it a negative. So if m1 is 2, m2 is minus 1/2, then the two lines are perpendicular. Now to summarize the forms for the equations of a line, you have first the general form, which is ax plus by plus c equals 0. It could also be written ax plus by equals c. You have next the slope-intercept form, which is y equals mx plus b. And then lastly, you have the point-slope form, which is y minus y1 is equal to m parentheses x minus x1, which is basically the definition of slope. Now, I would like you to find the equation of the line passing through the points 2, 3 and 5, 7 and post your answer in the drop box. Thank you.